So if you would work this out with me here, we're going to multiply these two numbers that are in scientific notation together. The first one is 4 times 10 to the 7th. The second one is 9 times 10 to the 3rd, both representing some pretty big numbers here. We're going to talk about how to multiply them together. The worst thing you could do right now is figure out, okay, well, what is 4 times 10 to the 7th in standard notation? It would be something like 440 million or something like that, some huge number, and then try to multiply that by whatever 9 times 10 to the 3rd is in standard notation. We're not going to do that. We're going to multiply these together, keeping them in scientific notation the whole time. First thing you need to do is multiply the base numbers, the original numbers as we've called them here, the 4 and the 9. Okay, we're going to multiply those base values together to get 36. Okay, and then you're going to multiply the tens together. Okay, now this is 10 to the 7th power times 10 to the 3rd power, and so when you multiply powers together that have the same base, like 10 in this case, you keep the base of 10 and you add those exponents. So we're going to get 10 to the 10th power, okay? And again, that came from multiplying this guy times this guy. That gave us that part of our answer, okay? So there's your answer. Now, one thing we do want to keep in mind that when we get an answer here, it's not necessarily in scientific notation anymore. And you may notice here that that is the case, that the base value here, the original number, is no longer less than 10. So we need to fix that. All right. So we're going to move the decimal, which is currently behind the 36 right here, and we're going to move it to the left one place. Okay, right there, to make 3.6 times 10. But now it's no longer to the 10th power because we moved the decimal to the left one place. You'd have to add one more to the exponent there. So now you're going to have a new exponent of 11. Okay. And so there's your final answer, 3.6 times 10 to the 11th. Okay, also want to show you similarly how to divide numbers that are in scientific notation together. Okay, so again, we actually kind of have a big number up here, 2.88 times 10 to the 3rd, divided by more of a smaller number, 1.44 times 10 to the negative 2nd power. But the process still pretty much remains the same. You can follow the last set of steps that we just talked about. You're going to, first of all, divide the base values, and if you work that out for a minute, you might want to use a calculator if you're not seeing what's happening there. The result would be 2. Okay, 2.88 divided by 1.44 is just 2. Okay, bring down that times sign and then divide the 10 to the 3rd power by 10 to the negative 2nd power. And if I may show you here, of course, we are going to subtract the exponent. We're going to keep the base of 10, but subtract 3 minus a negative 2, okay, which would give us 5, a positive 5, right? Doing keep, change there. Just want to make sure I cover my bases here and make sure we're all seeing where that exponent of 5 comes from. So our final answer will be 2 times 10 to the positive 5th power. And seeing where these numbers come from one more time, the 2 is coming from dividing the base values together, and the 10 to the 5th power is coming from when we divide 10 to the 3rd by 10 to the negative 2nd. Okay, I want to try and fit in here how to determine or determine what a light year is. Okay, and this is all in the context of where we're going now with talking about the universe. Pretty cool stuff. We're going to be talking about some very big numbers, and so the whole idea of using scientific notation is you're probably going to appreciate it a little more moving forward. Okay, here's some interesting facts though. The sun and the Earth are 93 million miles apart. Okay, did you know that? Maybe not. Now you do. It's 93 million miles away, and yet it can still burn you. It's pretty crazy. If you were to travel 80 miles per hour, like going pretty fast on the interstate, it would take you 1.1 million years to get to the sun. Okay, it would take you over 1 million years at 80 miles an hour to travel 93 million miles per hour. 93 million miles. Okay, if you were to travel at what seems to be this value right here, this is not so random, 670 million miles per hour. Okay, that's actually how fast light travels. It will only take you 8 minutes. Okay, so understand that the light from the sun takes 8 minutes to get from the sun to Earth. Okay, so if you can pause and think for a minute about that, if the sun were to stop burning right now, it would just burn out and stop shining. You wouldn't know it. We wouldn't know it for 8 minutes. Okay, you'd have 8 minutes to gather your belongings and say goodbye to everybody, but you wouldn't even know it happened. Okay, so that's pretty crazy, I think, and that's something that we're going to move forward with now. Okay, understanding the speed of light is that fast. We're going to talk about the light year now. Okay, so light year is actually the distance that light can travel in a full year. Okay, so like if you were to if you were to turn on a super powerful flashlight and just see how far its light could travel for a year, that would be considered the distance of a light year. Okay, so we're going to first look at the fact that, again, speed of light is 670 million miles per hour. It can travel 670 million miles in 1 hour. Okay, and then we're going to also consider the number of hours then in a year. Okay, and if we can multiply how far light travels in 1 hour by the number of hours in a year, then that will be the number of miles that light travels in that year. Okay, so thinking about this, of course, you're going to have to excuse my penmanship here, but it's going to be 24 hours in a day. Okay, and then what would we multiply that by to determine how many hours then are in a year? If there's 24 hours in 1 day, you of course would multiply that by 365 days, and that would be, get your calculators out, someone figure it out. I got 8,760. Okay, we're going to do a couple things with these numbers here. One thing I want to do is before we multiply this big number by this big number, although that would be a good thing to do, we're actually going to both represent them both in scientific notation. Okay, so 670 million, we're going to write that in scientific notation. Think about, here's the decimal at the end, so we're going to move it to the left 8 places. Okay, so I'll give you a second to think about how you'd write this number in scientific notation then. Okay, and then let's do the same thing, although it's not as big, let's do the same thing with the number of hours in a year, 8,760. Represent that in scientific notation, considering the decimal is starting here at the very end of the number. Move it over to make a number that is greater than or equal to 1 but less than 10, and we'd get something like this. Okay, so like I said, we're going to multiply then how many miles light can travel in an hour by the number of hours in a year, and that will give us the distance of a light year. Okay, so here are these values, and without giving you the answer right away, let's talk about multiplying 6.7 times 10 to the 8th by 8.76 times 10 to the 3rd. Using the example previously, of course, you'd multiply the base values together first, and when you get your calculators out and work that out, write that down as the first part of your answer. Get something like this. And then, of course, multiply the tens together, as we said. And so you get something like this. But let's make sure we don't forget about the fact that the decimal in this number needs to be moved over one place, because currently this base value is bigger than 10. Okay, make sure you watch out for that. So we move it over one place to make 5.8692 times 10 to the, of course you're going to, because you moved it to the left one time, you will add 1 to the exponent. And so we'll actually represent the number of miles that light can travel in a year by this value right here. Okay, so again, that's kind of hard to understand. Let's write that in standard notation. Okay, let's go back and put this value in standard notation. So we'd take the decimal and move it 12 times to the right. Okay, letting you kind of finish my sentence there. Make sure you remember which direction to move it in. And when you move the decimal 12 places to the right, you end up getting this value right here. And if you'd say this with me here, okay, starting out in the trillionth place, 5,869,200,000,000 miles. That is the distance that light can travel non-stop in 1 year. And so it's written both there in standard and scientific notation. And so bringing this back to the light year, okay, the light year then, when we talk about a light year, is that many miles. We're going to just say generally 5.8 trillion miles.